You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your educational journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. Security Orchestration, Automation, and Response, commonly called SOAR, represents the fusion of structured playbooks with automation tools to accelerate incident response. In modern cloud and enterprise environments, the sheer volume of alerts overwhelms human analysts. Playbooks provide codified, machine-executable actions that handle common cases with speed, consistency, and auditability. Their purpose is not to eliminate human judgment, but to reduce repetitive work, ensure standardized handling, and free analysts to focus on higher-level analysis. Think of SOAR playbooks as the recipe books of security operations. Each step is predefined, tested, and executed reliably when a trigger occurs. When governed well, they prevent mistakes that arise from improvisation during stress. The aim of this episode is to explore the principles, safeguards, and practices that make SOAR playbooks both powerful and defensible, ensuring they serve as trusted allies in detection and response at scale. A SOAR playbook is a machine-executable sequence of steps that responds consistently to a defined trigger. Unlike static runbooks, which provide instructions for humans, SOAR playbooks codify those instructions in software, allowing systems to execute them automatically. For example, a playbook might disable a suspicious user account, quarantine an endpoint, and notify analysts after a phishing detection. The power lies in repeatability. Every incident type is handled the same way, reducing variance and error. It is like setting up autopilot in aviation. The pilot still oversees, but repetitive adjustments are made with precision. SOAR playbooks embody institutional knowledge, transforming tribal expertise into structured, automated action. By converting manual steps into automated flows, they bridge human oversight with machine speed, ensuring responses remain fast, accurate, and scalable. Triggers are the events that initiate SOAR playbooks. These may come from security information and event management, SIEM alerts, cloud posture tools, endpoint detections, or even help desk ticketing systems. Triggers are like doorbells. They signal the start of an interaction and launch the sequence of response steps. Without reliable triggers, playbooks may execute unnecessarily or fail to activate when needed. Designing effective triggers requires filtering noise and setting thresholds for severity or confidence. For example, a trigger may launch only when multiple detection sources corroborate suspicious behavior. By defining triggers carefully, organizations ensure automation activates when justified, not in response to false positives. This precision balances speed with accuracy, preserving trust in automation and reducing the risk of wasted effort or accidental harm from unnecessary actions. Enrichment steps add critical context to alerts before containment actions proceed. A raw SIEM alert might only include an IP address or username. Enrichment queries external data sources to add details such as asset ownership, geolocation, known threat intelligence, or recent activity history. Enrichment is like investigating before acting. It turns fragments of data into actionable intelligence. For example, before disabling a user account, enrichment might confirm whether the user is active in the HR system, reducing false positives. Threat intelligence lookups, asset databases, and identity stores all contribute to this stage. Enrichment ensures that playbooks act with knowledge, not blind reaction. It builds confidence that automated responses are appropriate and justified, reducing operational friction and strengthening the defensibility of actions taken at machine speed. Normalization ensures that events from multiple providers map into a consistent schema, allowing playbooks to branch deterministically. Alerts from different tools may describe the same concept, such as failed login attempts in varied formats. Without normalization, automation logic would fracture into countless exceptions. Normalization is like translating multiple dialects into a shared language, ensuring that all alerts can be compared and processed consistently. In cloud, where multi-vendor tools dominate, Normalization is essential for portability and scalability. For example, mapping SRCIP and source address into a common field allows decision branches to evaluate them uniformly. Normalization also simplifies auditing, as evidence logs reflect standardized fields rather than vendor-specific jargon. By enforcing a unified schema, organizations create a strong foundation for playbooks, ensuring automation remains predictable, maintainable, and interoperable across diverse ecosystems. Decision branches guide playbook flows by applying logic to severity, confidence, and business criticality. Rather than treating every alert equally, branches ensure proportionate response. For example, if enrichment reveals a low-confidence malware detection on a non-critical system, the playbook may close the alert with minimal action. Conversely, high-confidence findings on crown jewel systems trigger escalation and containment. Decision branches are like traffic signals. They route incidents safely and efficiently based on conditions. In cloud environments, business criticality tags, such as production versus development workloads, inform branching logic. By embedding these thresholds, organizations avoid overreaction to minor events, while ensuring major threats are addressed decisively. Branches balance automation with contextual intelligence, reinforcing trust that machine actions reflect both technical severity and business impact. Human-in-the-loop checkpoints add governance to automated playbooks. Some actions, such as mass account suspension or firewall reconfiguration, carry potential production impact. To prevent harm, playbooks pause at defined checkpoints, requesting explicit analyst approval before proceeding. This design is like requiring two keys to launch critical systems. Automation prepares, but humans decide. Human-in-the-loop stages provide accountability, ensuring sensitive actions receive oversight. They also give analysts visibility into context assembled by enrichment, improving confidence in their decisions. In cloud security, checkpoints might appear before revoking privileged identities or shutting down clusters. By blending automation with human review, organizations achieve both speed and control, demonstrating that SOAR is not about blind execution but about guided acceleration of trusted workflows. Safety guards validate preconditions before executing impactful actions. Guards may check whether maintenance windows are active, whether alternative routes exist, or whether changes would exceed defined blast radius thresholds. These safeguards are like safety latches on machinery. They prevent accidents when conditions are unsafe. For example, before quarantining a VM, a playbook may validate that it is not part of a critical cluster without redundancy. Guards also ensure compliance with change control practices, reducing conflict with IT operations. By embedding safety checks, organizations prevent automation from becoming reckless. Guards preserve operational trust by proving that playbooks act responsibly within defined boundaries. They also reassure auditors and stakeholders that automation does not sacrifice governance for speed, but instead enforces it more reliably than ad hoc human judgment. Idempotency design ensures that rerunning a playbook produces the same end state without unintended side effects. In complex cloud environments, retries and overlapping triggers can re-execute flows. Without idempotency, actions like revoking tokens or creating tickets could multiply unnecessarily, creating chaos. Idempotency is like hitting the save button repeatedly. It should not create new copies each time but confirm the state is preserved. Playbooks achieve this through state checks, unique identifiers, and conditional logic. For example, before disabling a user account, the playbook verifies whether it is already suspended. Idempotency ensures predictability, reducing noise and avoiding accidental harm. It transforms automation into a reliable ally rather than a brittle risk. By designing for idempotency, organizations make playbooks robust under real-world conditions where triggers repeat and systems fail intermittently. Credential handling is a sensitive challenge in playbook design. Storing long-lived secrets in scripts introduces serious risk. Instead, playbooks should retrieve credentials from secure vaults, use role-based access, or issue short-lived tokens for each action. This approach is like borrowing keys from a lockbox that records every use, rather than leaving master keys hidden under a mat. Cloud-native security services, such as identity-based access roles, often eliminate the need for static secrets altogether. Credential governance not only prevents compromise, but also strengthens defensibility by showing auditors that sensitive operations were conducted securely. Poor practices, like embedding administrator credentials in scripts, are considered anti-patterns that undermine automation. Robust credential handling ensures that SOAR playbooks protect secrets while executing responses, proving that security automation extends trust not only to outcomes, but also to the methods used. Rate limits, retries, and exponential backoff protect provider APIs from overload during automation. Playbooks may query threat intelligence or issue remediation calls in bulk. Without throttling, they risk flooding systems or being blocked by providers. Rate control is like pacing footsteps on a long run. Sustainable speed prevents collapse. Back-off strategies retry failed requests intelligently, avoiding repeated stress. In cloud, where APIs govern every action from account suspension to firewall updates, respectful usage is critical. By embedding limits and retries, organizations design automation that is resilient, efficient, and compliant with provider best practices. These controls also prevent partial execution, where some actions succeed and others fail silently. Proper pacing ensures that automation complements infrastructure rather than disrupting it, reinforcing that playbooks must respect both technical and operational ecosystems. Logging is central to SOAR defensibility. Every input, decision, action, and result must be captured with immutable timestamps. Logs create the audit trail that proves automation behaved as intended and supports later review. It is like keeping black box recorders in aircraft. They enable investigation when outcomes are disputed. Logs must include context from enrichment, decision branches, and checkpoint approvals, ensuring transparency. In cloud environments, immutable logging to centralized stores or worm systems ensures integrity. Without logs, automation becomes opaque, eroding trust. With them, it becomes explainable and defensible, even under regulatory scrutiny. Logging transforms playbooks into transparent workflows rather than hidden processes, ensuring that speed does not sacrifice accountability. It also supports lessons learned, enabling teams to refine logic over time. Version control applies software engineering discipline to playbooks. Every change should be tracked, peer-reviewed, and capable of rollback to a known good state. This prevents errors from creeping into production untested. Versioning is like keeping drafts and edits in publishing. It shows how processes evolved and allows return to trusted versions when needed. Playbooks stored in repositories can be tested, branched, and documented like code. Peer review ensures logic is scrutinized for both technical accuracy and security governance. In cloud contexts, version control also supports regulatory defensibility, demonstrating that playbooks are not ad hoc but subject to structured change management. By embedding versioning discipline, organizations reduce risk, increase collaboration, and strengthen confidence in automated workflows. Unit tests and dry run simulations validate playbooks before they touch production systems. Tests confirm that logic paths execute correctly and that permissions align with least privilege. Dry runs simulate execution against test data, ensuring safety and predictability. This process is like fire drills. Teams practice before facing real flames. Without testing, playbooks risk unintended impacts in live environments, undermining trust. In cloud, sandbox environments and test accounts provide safe venues for validation. Unit testing also accelerates iteration by catching logic flaws early. By making testing mandatory, organizations prove that automation is engineered responsibly, not recklessly. Testing transforms playbooks from fragile scripts into resilient, production-grade processes that deliver consistent, trusted outcomes under real-world conditions. Exception handling ensures playbooks can fail gracefully. When steps encounter errors, such as unreachable APIs or insufficient permissions, the system must record the failure, attempt compensating actions, and escalate to human analysts. Exception handling is like seatbelts. They protect when things go wrong. Without it, failures may cascade, leaving incidents unresolved or, worse, worsening them. In cloud, exception paths may include rerouting requests, retrying with alternative methods, or raising service tickets for analyst follow-up. Proper handling ensures incidents remain managed, not abandoned. By embedding exception logic, organizations create resilience in automation, proving it can adapt to unpredictable realities. Exception handling strengthens trust, ensuring playbooks serve as reliable teammates, not brittle liabilities. Compliance tagging integrates SOAR playbooks with broader governance frameworks. Each execution can be tagged with control IDs, case numbers, or regulatory requirements, linking actions to compliance obligations. For example, a phishing playbook may tag evidence with PCI DSS identifiers for audit readiness. Tagging is like filing documents in labeled folders. It ensures artifacts are organized, searchable, and defensible. In cloud, where audits often require rapid evidence production, compliance tagging accelerates reporting and reduces burden. It also demonstrates maturity, showing regulators that automation contributes directly to control assurance. By embedding compliance into playbooks, organizations prove that response is not only fast but also accountable, aligning operational workflows with regulatory and contractual expectations. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Identity abuse is one of the most common SOAR playbook use cases. When alerts indicate compromised credentials, the playbook can disable active sessions, revoke tokens, and rotate keys automatically. These steps ensure that attackers cannot continue exploiting stolen identities. Think of it like changing locks after a burglary attempt. Even if the thief has keys, they no longer work. Least privilege principles guide containment, limiting disruption while protecting business-critical operations. For example, rather than disabling all accounts, the playbook may revoke access only for the compromised session. Automation speeds this response, preventing lateral movement while analysts investigate root cause. In cloud, where tokens and API keys proliferate, automation ensures consistent, rapid identity hygiene. Well-governed playbooks make identity abuse a manageable incident rather than a prolonged crisis, proving the power of orchestration to safeguard the human and machine accounts at the core of digital operations. Misconfiguration handling is another critical playbook pattern. Many breaches result not from sophisticated attacks, but from exposed storage buckets, overly permissive firewalls, or forgotten test resources. A SOAR playbook can quarantine public resources, apply deny policies, and generate remediation tickets automatically. This is like closing open windows before a storm. Basic steps that prevent major damage. In practice, automation ensures misconfigurations are corrected within minutes rather than weeks. Playbooks may also notify resource owners, providing context and requiring confirmation for permanent changes. Cloud environments, where infrastructure is spun up and down constantly, demand such guardrails to prevent drift. Automated misconfiguration response transforms posture management from periodic scans into real-time resilience, proving that proactive orchestration protects both compliance and business continuity. Malware incidents demand swift isolation to prevent spread. SOAR playbooks can quarantine affected storage objects, trigger antivirus or sandbox scans, and block associated indicators of compromise across firewalls and endpoints. It is like containing a spill before it contaminates the entire water supply. Fast action limits impact. Playbooks also ensure evidence preservation by hashing suspicious files and storing them securely for later analysis. Automation provides scale. Thousands of objects can be scanned and contained simultaneously, a task impossible for manual teams. By combining isolation, enrichment, and blocking, playbooks deliver layered defense. In cloud, where malware may propagate through shared storage or CI/CD pipelines, automated containment is vital. Playbooks transform chaotic outbreaks into structured responses, ensuring consistency and auditability while reducing mean time to contain. Malware automation proves the value of SOAR as both shield and scalpel. Phishing remains a leading entry point for attacks, and playbooks provide a structured defense. Automated workflows can parse reported messages, detonate attachments in sandboxes, check sender domains against reputation feeds, and orchestrate user notifications. This is like a mailroom sorting system. Suspicious packages are inspected thoroughly before release. Playbooks may also integrate with identity platforms to flag accounts that clicked malicious links for additional monitoring. Automation accelerates analysis, ensuring that response keeps pace with phishing campaigns that may target thousands of users simultaneously. Human-in-the-loop checkpoints can approve mass mailbox purges or domain blocks, balancing speed with caution. By embedding phishing response into SOAR, organizations not only reduce dwell time but also demonstrate defensible governance. Playbooks standardize processes that might otherwise vary across analysts, delivering consistent protection against one of the most persistent threats in cybersecurity. Network anomalies require rapid containment, and playbooks are well suited to this task. Automated workflows can tighten overly permissive security groups, update firewall rules, or mirror traffic for inspection when unusual flows are detected. For example, if a workload suddenly begins communicating with a forbidden geography, the playbook may block traffic and alert analysts. This is like rerouting traffic away from a collapsing bridge. Quick, decisive action prevents catastrophe. Playbooks provide structured escalation, ensuring that network changes follow safe patterns with rollback options. In cloud, where ephemeral workloads shift constantly, automated response ensures agility without sacrificing control. Network playbooks prove that orchestration is not only about stopping attacks but also about managing dynamic infrastructure safely. They transform anomalies into managed incidents rather than unchecked risks. Evidence capture is a foundational element of playbook design. Every action logs, snapshots, and file hashes must be preserved in tamper-resistant storage. Write once, read many, or once systems provide immutability, while metadata establishes chain of custody. Capturing evidence is like photographing a crime scene before cleaning. It preserves proof for investigation and accountability. In cloud environments, playbooks can automatically export logs, capture system states, and store them securely. This reduces analyst burden and ensures no step is forgotten during high-stress incidents. Evidence capture also satisfies compliance frameworks, where demonstrating control operation is as important as containing threats. Without evidence, actions may be defensible operationally but fail legal or regulatory tests. With automated capture, SOAR delivers both speed and defensibility, showing that incident response is accountable from trigger to closure. Case management integration ensures that playbook actions are reflected in organizational workflows. Tickets are automatically opened, assigned, prioritized, and tracked against service-level objectives. This is like connecting an emergency response team to dispatchers. Automation ensures visibility and accountability. Integration prevents incidents from slipping through cracks, ensuring every action has an owner and timeline. It also allows managers to track metrics such as mean time to resolution or case backlog. In cloud, where incidents often cross teams and domains, central case management creates cohesion. Playbooks become not isolated scripts but part of enterprise governance, aligning with IT service management and compliance requirements. Integration demonstrates maturity. Automation is not just reactive but embedded into business processes that sustain accountability and oversight throughout the incident lifecycle. Provider coordination is another key playbook capability. Many incidents require engaging cloud or SaaS vendors for assistance, whether to escalate service tickets, request forensic data, or validate containment. Playbooks can invoke approved support channels, populate case numbers, and track request identifiers within the broader incident record. This ensures that external interactions are consistent, documented, and auditable. It is like filing insurance claims with proper paperwork. Speed and accuracy matter. Without integration, analysts may forget steps or duplicate efforts under pressure. With coordination embedded, responses become predictable and defensible. In cloud, where dependencies span multiple providers, orchestrated coordination proves essential. It turns fragmented support engagements into structured, traceable workflows, reinforcing that automation strengthens not only internal processes but also external accountability. Multi-cloud environments demand portability, and playbooks must be designed with abstraction. Rather than embedding provider-specific commands, actions can be wrapped in adapters that normalize operations across AWS, Azure, or Google Cloud. This is like using universal power adapters when traveling. One interface works across many outlets. Abstraction ensures that playbooks remain maintainable, reducing duplication and provider lock-in. For example, an identity disable function may call a generic adapter, which then maps to the appropriate provider API. Multi-cloud patterns also simplify training, as analysts interact with consistent playbooks regardless of underlying infrastructure. By designing with portability, organizations future-proof their automation strategies, proving that SOAR investments scale with business needs. Abstraction ensures that automation supports resilience in heterogeneous environments rather than fragmenting into siloed scripts. Metric collection is essential for continuous improvement. Playbooks should track key indicators such as mean time to acknowledge, mean time to automate, and mean time to contain. These metrics provide feedback loops showing where automation succeeds and where refinement is needed. It is like tracking lap times in athletics. Improvement comes from measurement. Metrics also support business reporting, demonstrating return on investment for automation. In cloud, where scale and speed are critical, metrics validate that automation achieves its promise of faster, safer response. They also reveal bottlenecks, such as frequent human-in-the-loop delays, guiding process redesign. Without metrics, playbooks risk becoming static. With them, they evolve alongside threats and infrastructure. Metrics transform SOAR from reactive tooling into a disciplined, continuously improving practice. Resilience design ensures playbooks themselves can withstand disruption. Runners, queues, and state stores must be duplicated across zones to prevent single points of failure. It is like building fire stations in multiple neighborhoods. Emergencies cannot wait for distant responders. In cloud environments, playbook engines must survive outages and scale elastically. Resilience design also involves checkpointing state, so executions can resume after interruptions. Without these safeguards, automation risks becoming brittle, failing precisely when most needed. With resilience built in, playbooks provide assurance that incident response remains reliable under stress. Designing for resilience proves that automation is not only fast but also durable, aligning with the same continuity principles applied to production systems. Cost controls temper the enthusiasm of automation by capping expensive actions such as enrichment lookups, sandbox detonations, or bulk data movements. Each adds value but also consumes resources. Cost controls are like thermostats. They keep spending within safe bounds. In cloud, unlimited automation may generate surprise bills or strain capacity. Playbooks must include quotas, budgets, and compensating paths when thresholds are exceeded. This ensures automation remains sustainable, balancing security with fiscal responsibility. By embedding cost awareness, organizations demonstrate governance not only of risks, but also of resources. This balance sustains executive support for SOAR, proving that security automation delivers value without unchecked expense. Post-incident hooks extend automation beyond containment into learning. After closure, playbooks can trigger lessons-learned tasks, rule updates, and exception reviews. This ensures continuous improvement becomes part of the workflow, not an optional afterthought. It is like debriefing after emergency drills. Analysis strengthens future readiness. In cloud environments, post-incident automation may update detection rules, refine enrichment sources, or adjust guardrails. These hooks demonstrate maturity, proving automation adapts as threats and systems evolve. By capturing knowledge systematically, Organizations prevent recurrence and accelerate institutional learning. Post-incident integration ensures SOAR contributes not only to response but also to long-term resilience, reinforcing the value of automation as part of governance and improvement cycles. Anti-patterns illustrate dangerous misuses of SOAR playbooks. Common examples include alert to delete actions that remove suspicious resources without enrichment, unapproved mass changes that disrupt production, and hard-coded administrator credentials embedded in scripts. These are like shortcuts in construction, faster at first, but structurally unsound. Anti-patterns erode trust, undermine defensibility, and may cause more damage than the threats they address. Recognizing and avoiding them is essential for responsible automation. By embedding guardrails, reviews, and testing, organizations prevent anti-patterns from creeping into production. They demonstrate that SOAR is engineered with the same discipline as any critical system, not as reckless experimentation. Avoiding anti-patterns ensures automation remains a source of strength, not fragility. From an exam perspective, SOAR playbooks test the ability to choose automation patterns, guardrails, and evidence practices that produce safe, auditable outcomes. Candidates may face scenarios asking how to design identity abuse playbooks, prevent misconfiguration drift, or ensure evidence integrity. Success depends on reasoning. Why enrichment matters before action, how checkpoints balance speed with control, or how ID impotency prevents side effects. Exam readiness emphasizes understanding the balance of automation with governance. Mastery demonstrates the ability to design playbooks that are fast, safe, and compliant, delivering value in real-world operations while standing up to regulatory and audit scrutiny. In conclusion, well-governed SOAR playbooks combine context, guardrails, and precise actions to deliver fast, defensible response at scale. They transform manual tasks into automated workflows that enrich, decide, and act consistently. Playbooks handle diverse threats, identity abuse, phishing, malware, and misconfiguration, while preserving evidence and integrating with case management. Guardrails such as human checkpoints, ID impotency, and immutability ensure safety and defensibility. Metrics, cost controls, and post-incident hooks drive continuous improvement. By avoiding anti-patterns, organizations preserve trust in automation, ensuring it remains a reliable ally. SOAR proves that automation and governance are not opposites but partners, working together to deliver resilient, auditable, and sustainable security operations in complex cloud environments. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.